Hello everyone, this is Maruti from Group 2, and today we are here presenting our machine learning app 3. So as we see on the screen, the first section is about the employee data set. So this data set provides insights into various attributes related to employees such as their education, the year they joined, the city they based in, their age, gender, and so on. And the data has fields such as whether an employee has been benched or their experiences in their current domain and a binary field indicating they have left the company. And the overall goal of this dataset is to utilize machine learning techniques to predict employee attrition. And three main areas of focus will be on dimensionality reduction and hyperparameter tuning to ensure the machine learning modules run optimally and enhancing the learning performance, which improves the overall productive power of the model. And coming to the second snippet, which we implemented the importing libraries. And so this cell is dedicated to importing all the necessary libraries and modules for data manipulation, visualization, and machine learning. So as we can see, libraries like Pandas and NumPy are for data handling and mathematical operations, while Seaborn and Matplotlib are for visualizations. And scikit-learn is a prominent library for machine learning, and multiple modules are important from it for classification, regression, model selection, and metrics. And coming to the third snippet, which we use to load the dataset, the dataset title the employee.csv file is loaded into the data frame named data. This is a snapshot of the initial few rows of the dataset, showcasing some entries and providing a visual representation of the data structure. And each row represents an employee's data, and the columns contain the various attributes as I discussed earlier. And the fourth snippet, which is used for displaying the head and the data types. The head function provides a glimpse of the first few rows of the data set. This allows a quick verification to ensure the data has been loaded correctly. And following that, the D types function displays the data type of each column in the dataset. This is crucial for understanding the nature of each attribute, for example, numerical and categorical, etc. And so, which aids in pre-processing steps. And from now on, my teammate Madhu will take over the presentation. Thank you.
Yeah, now I'm going to explain about how we converting object data type into categorical data type. So identify categorical columns based on unique value count. From the data, we adjust the threshold to check the count of unique values, where we set threshold equal to 5 and we checking categorical values. After that, we use head options to check to pop up a few rows in the snipping tools like snap 6, and after that we find missing values in the data. So here we can see that payment tier and our gender and experience in current domain has some missing values. So we now we're gonna handle the missing values. So the like how we handle is that null values with the main for numerical values and made for categorical values. So after that we check with head from function. It returns a few rows where we can see. After that we check with some option. There we can see null values. So now my team and Vishnu will continue.
Yep. Hello everyone. We are here converting categorical variable to numerical using label encoder. For that, we use data preprocessing, which we import the skit learn preprocessing module. Using a label encoder to transform categorical data into a numerical values. Here you can see after using this code, we can get the education, city, payment type, gender, ever benched and leave or not. So, and coming to this code snippet number 12, it is saying like use a label encoder to transform Yes, to categorical data into numerical value only. Here is the output for it. And next, we are separating the target variable where we display the first few rows of the data set to understand its structure. And coming to next, it is about data splitting into 70 data, I mean splitting data into 70% training and 30% test data. Like split the data into training, X train and Y train, and testing we use X test and Y test sets. And coming to this random forest classifier, where it create a random forest classifier with a specific hyper parameters, I mean, and train RFC on training data, and we make the predictions on the test data and calculate accuracy. And here is the output for random forest score. And my teammate will continue from here on. Thank you.
Hello everyone, this is Ashok. So I'm gonna continue from code snippet 16. So in this line of code, we're using a SVM function, which is a support vector machine. This SVM creates an instance of the support vector machine classifier and with a default hyperparameters. And next we are using SVS50. This line trains the SVM classifier on the training data. And this code of snippet trains an SVM classifier on a training dataset, uses it to make a predictions on a test dataset, and then calculates and prints the calculation classification accuracy on the test data. This accuracy is a measure of how well the SVM model is performing in classifying the data. Coming to the 17th line code. So dimensionality reduction. This code demonstrated the application of principal component analysis for dimensionality reduction. A reduced set of features is often beneficial for visualization and model efficiency. Then n component parameter is set to 5, which reduces the data to 5 principal components. The data is transferred using PCA and the result is stored in PCA result. A new data frame, data underscore PCA, is created to hold the reduced dimensions. Additionally, the PCA result is concatenated with the target variable to create the final DFPCA data frame. This dimensionality reduction technique simplifies the dataset while retaining essential information. Coming to the next course. Uh, so this is the principal component analysis code for dimensionality reduction on a dataset and creating a new data frame with the reduced dimensions. So, this code performs PCA to reduce the dimensionality of the dataset to 5 principal components and then combines the reduced data with the original target variable. So creating a new data frame or DF underscore PCA for further analysis or modeling while retaining information about the target variable. And coming to the next code. So these are the data sets ready to be used for the training and evaluating the machine learning model, such as classifier using the reduced dimensional features obtained from PCA. And coming to the next one, this is very similar to the previous code, the training and evaluation support vector machine, but with some modifications to use the reduced dimensional features obtained from PCA for training and testing. So in conclusion, this code trains an SVM classifier with the reduced dimensional features obtained from PCA on a test dataset and then calculated and prints the calculation accuracy on the test data. Assessment of how well the SVM model performs when trained and evaluated using these reduced features. So next line of course will be explained by my teammate Sirisha. Thank you.
Hello everyone, this is Sirisha Ketnani. I'm going to talk about decision tree after dimensionality reduction. So here this code trains and evaluates a decision tree classifier after applying dimensionality reduction. First one, we are initializing decision tree. This decision tree classifier is created and then this classifier is used for making predictions based on the data. which we provided. And the second one, decision tree dot fit. So the decision tree classifier is trained using the trained data. XT trained are the features, YD trained are the corresponding labels. After applying the dimensionality reduction, the model learns patterns in the data. And the third one is importing metrics by using import keyword. This line import two metrics, accuracy score and classification report, and then making predictions by using decision tree dot predict. So the trained model decision tree is used to make the predictions on a separate set of data xt underscore test, which the model has never seen before. So the next thing, we are using calculating accuracy by using accuracy score method. So the accuracy score of the model is calculated by comparing the predicts label, YD prediction and YD test. This tells you how many predictions were correct in this by using in this line of code. And the next one, we are printing the accuracy by using print, the decision tree accuracy. So this line of code will print the result of that particular printing accuracy. Then we are going to 22 line of the code, and this is random forest classifier after dimensionality reduction. Here, the code involves training and evaluating a random forest classifier after applying the dimensionality reduction. First one, again, we are initializing the random forest classifier, and then we are doing training the classifier rfc.fit. We are passing xt underscore train and yd underscore train. So these are the labels of the corresponding x and y, xt train and yd train. After applying the dimensionality reduction, the model learns patterns in the data. And the next one is making predictions by using rfc.predict of xt underscore test, which model has never seen before, by using this xt underscore test and the trained model of RFC. The next one is we are using calculating accuracy by using accuracy score method. We are passing to YD underscore test and target predict is the parameters we are passing to that method, which this tells you how many predictions were correct in this based on the data. And the next one is printing accuracy. By using print keyword, we are printing the line of random forest score. This and the next one is import matplotlib.pyplot as PLT. This line of code defining this imports the MATLAB plot library for creating visualizations. And then we are defining the accuracy scores by using accuracy scores before and after. We are defining it here. And then we are defining the methods. The methods we are defining as RFC, SVC, and DT. This list contains the names of the algorithms, the same as usual, like we mentioned RFC, SVC, and DT are the algorithms we mentioned. And then we are creating a figure by using plt dot figure. By using this, we are creating the figure, and then we are plotting the accuracy scores by using plt dot plot. And then we are setting the labels and title by using plt dot x label, y label, and title. And then we are adding legend to that plot plt, and we are displaying the grid, and we are displaying that plot to the grid. In this summary, this code creates a line of plot comparing accuracy scores before and after dimensionality reduction for different machine learning algorithms. The x-axis represents the methods and y-axis represents the accuracy scores. This visualization helps in understanding the impact of dimensionality reduction in the model of performance in this graph. So the next one, hyperparameter tuning. Here, this code focuses on hyperparameter tuning for a decision tree classifier using randomized search CV. It narrows down key parameters like criterion, max depth, minimum sample split, and minimum sample sleeve by running a limited number of iterations. It efficiently finds the best hyperparameters. So the tuned model's accuracy is evaluated on a test dataset, providing a fine-tuned decision tree model for enhanced performance and generalization. Next, the last one, 24th, defined a reduced set of hyperparameters to search. So here we are defining the hyperparameters. So a set of hyperparameters to explore a defined and including criterion max depth and minimum sample split and minimum sample leaf. So create randomized search CV. We are using decision tree classifier of random underscore state equal to 42. This search will run the 20 iterations, which can be adjusted based on the available resources. And then we are fit the model. The randomized search CV is fitted to the training data of X train and Y train. This means it will try different combinations of hyperparameters to find the best performing model. And the next one, find best hyperparameters. The best hyperparameters identified by search are stored in best underscore params, and then get best model by using get best model found during this search is stored in best underscore model, and then make predictions by using x underscore test, and the results can be stored in y underscore pred underscore tuned. By using calculate accuracy, the accuracy of the tuned model is calculated by comparing the predicted labels y underscore pred underscore tuned and with the actual labels of y underscore test. And then we are printing the accuracy. The accuracy model is printed to the console, and this case is approximately 82.81%. And then final one, learning performance improvement. Here we have classifier selection.
I'll continue from here, Sirisha. Yeah. So after seeing all the algorithm models after dimensionality reduction, so we are going to try the k-fold cross-validation to improve the performance of the algorithm. So generally, this k-fold cross-validation is a valuable technique for evaluating how well a model performs across different subsets of the data. So if you go through the code, here we are using decision tree classifier, and then here we are specifying number of folds for the cross validation. Like it can reproduce data for data shuffling and randomness of the reproducibility. So next here we are initializing the k-fold cross validator, and after doing all the cross validation metrics here, we are printing the accuracy score, which is 96, and which is good. Even after performing dimensionality reduction, we just got, if you go up a little up, and if you see here, we got 82%, but after using k-fold cross validation here, we got 96%, which is the best percent we can do. So these graph shows the so after taking all the accuracies from the algorithms, like here we are showing the decision tree classifier accuracy at different stages. Like first the normal algorithm which we applied on the data set, here we got around 80% of the accuracy, and after using dimensionality reduction, we almost got like 82%. And by using hyperparameter tuning, here we got a little less, like around 82 or something. But after using k-fold cross-validation performance metric, here we got almost 96%. So after coming to the summary, so the first initial accuracy of the random forest is 82%, and after using dimensionality reduction, here we got almost 87%. So random forest demonstrates stronger performance after dimensionality reduction. And when it comes to support vector classifier, the initial accuracy is 65, and after using dimensionality reduction, it is 79%. So it is also shown that dimensionality reduction significantly improves SVC performance. So the third one is decision tree. So here, if you can see, the initial accuracy of the algorithm is 80%, and after using dimensionality reduction, it is 95%. And accuracy after hyperparameter tuning is 82%. So the conclusion is, so dimensionality reduction and hyperparameter tuning leading to significant accuracy improvement. But among these three, the dimensionality reduction performs best for the decision tree for finding the accuracy. And when it comes to the last one, like when we try to improve more of the algorithm performance, if we used k-fold cross validation, and here we got 96, which is better than the dimensionality reduction. So in summary, the decision tree model, particularly after k-fold cross validation, dimensional reduction, and hyperparameter tuning, stands out the best performing approach for this data set, achieving the highest accuracy. Thank you.